Lesson 4-4 on rational function features. Okay, students, you are going to see how in this section, the skill set that you will continue to use throughout is the factoring method. And the methods are going to help you determine certain features of rational functions so that you are able to graph. So let us start off with the first of 6 examples for which values of x is the expression undefined. When we are talking specifically about undefined values, we are looking for values that cause the denominator to become 0. Okay, so when I asked you to determine what the undefined values are, I'm asking you to find what x values cause our denominator to become 0. Now remember, we do not want our rational to ever divide by 0 because we would end up with an undefined value. And I suggest that students kind of use the letters U and DE as the beginning of the word under so that you can remember that specifically I am talking about your denominator value, okay? I'm asking you to find out what will cause that denominator value to become 0. So what I need you to do always is to factor, especially when your degree is 2 or higher. So this here is specifically a difference of squares problem. 2 squared numbers that are subtracting, and we know that a squared minus b squared will always end up having a format of a plus b times a minus b, where in essence you square rooted those square terms, okay? All right, so x squared minus 16 can be rewritten as x minus 4 times x plus 4. So what x values cause our denominator to become 0? Well, what I'm going to do is set the first factor equal to 0 and solve. Add 4 on both sides, and we get x equals 4. So here's our first undefined value. Take the x plus 4 and do the same thing. I would subtract 4 on both sides to isolate my x, and x will end up being negative 4. So my 2 undefined values, in other words, the 2 values that would cause my denominator to become 0 are 4 and negative 4. And you can check, because if I substituted 4 into x squared minus 16, I would get 4 squared minus 16, and 16 minus 16 is indeed 0. And the same thing is for the negative 4 all squared. Negative 4 all squared is still 16 minus 16, and we're getting 0. Not that you have to do any checking, but I just wanted to show you what undefined means. So list the x values that cause your denominator to become 0 is undefined. Let's move on to the next question. Example number 2. So in example number 2, we are asked to find vertical asymptotes. So vertical asymptotes are similar in process to finding undefined values. So here's what I need you to ask yourself. What x values cause the remaining, let's fix that, remaining denominator factors to become 0. All right, so the key word in this one is remaining. So in the previous example, I had you, in finding undefined values, just look at the denominator, factor, and set them equal to 0, and you gave me the answers, okay? Here I'm also asking you to look at the denominator, but this time I used the word remaining. And so here's why I need you to see the difference between example number 1 and example number 2, all right? Let us go ahead and look at this problem. F of x equals x squared plus 8x minus 9 over 2x squared minus 12x. But I would like you instead to factor both the numerator and the denominator when it comes to vertical asymptotes. So since here in this particular trinomial upstairs in the numerator, the a value is a 1, we notice that this is the factoring trinomial that's super easy because all we have to do is set up our parentheses, and we have to ask ourselves the question, what two numbers multiply to get -9, which is our c value, that at the same time add to give me a positive 8. Well, the two numbers that multiply to give me -9 that add to be 8 would be a positive 9 times a -1. Okay, let's look at downstairs. Downstairs, we see 2x squared minus 12x. I am going to use the GCF factoring method to simplify and write this as a product. 2x is my greatest common factor. If I divide both of these by 2x, as you're supposed to do with GCF, what would remain is in parentheses. So 2x squared divided by 2x is an x. 12x divided by 2x is a -6. So here is my fully factored rational, converting x squared plus 8x minus 9 to x plus 9 times x minus 1, and converting 2x squared minus 12x to 2x and x minus 6. What I need you to do is look at this rational and see if there anything that can cancel. In this particular problem, nothing can be canceled. There were no like numerator and denominator factors. So to find the vertical asymptotes, I'm supposed to look at the remaining factors in this rational, and the remaining factors are these because nothing canceled, okay? And so all I'm going to do is take each factor, set them equal to 0, and solve. Divide by 2 on this one. So my vertical asymptote is going to be x equals 0. Set this equal to 0, solve, add 6 on both sides, and the other vertical asymptote is x equals 6. Okay? Now here's what I want you to understand, that let's say this happened, for instance. So this is a complete different problem, by the way, has nothing to do with this one. So let's say instead our factored rational looks something like this. Instead of 2x times x minus 6, let's say it was 2x times x plus 9, okay? If I had asked you to find the vertical asymptotes of this made-up example problem that I'm giving you, notice that this x plus 9 would cancel with this x plus 9. So that would leave me with x minus 1 over 2x. So if I asked you to find the vertical asymptotes of this problem, please note that the remaining factor is only 2x. That was the only one that was left over. So 2x set equal to 0, and then I divide by 2 on both sides. That means for this problem that I made up, the vertical asymptote would only be x equals 0. If I had asked you in this made-up problem what the undefined values were, you would use all of the ones that were listed in the denominator. So in this case, your undefined values would be 0 and x equals -9. So hopefully you're seeing the difference between example 1 and example 2. Example 1 says list all the factors, and example number 2 says what factors were left over and set those equal to 0, okay? So that's the difference between those two, okay? Let's move on to example number 3. So pause the video and copy down this problem. And do me the favor and go ahead and copy down what you see here. And we will discuss what you do in this problem. Okay, so thank you for doing that. So next on the agenda are horizontal asymptotes. Now here's the deal with horizontal asymptotes. You will not need to do any factoring when it comes to determining horizontal asymptotes. All I need you to do is compare the degree of your numerator, I'm going to use NUM, and your denominator. Okay? I need you to compare those numbers. Now, if you have forgotten what degrees mean, degrees are the highest power or exponent of your polynomial, okay? So let's look at this problem. 5x squared plus 3x over 6x squared plus 33x minus 63. Let's compare the degrees. Well, the highest exponent in the numerator was a 2. The highest exponent in the denominator was a 2. If we compare those degrees, the numbers are the same. So look at your options, your bullet point options, and you'll notice that bullet number 2 says that if the degree in your numerator is equal to the degree in the denominator, this is what you're supposed to do. It says your equation is going to be in this format. Y equals the leading coefficient of your numerator over the leading coefficient of your denominator. So what is the leading coefficient of my numerator? Well, that is the coefficient of your leading term, and my leading term is the one that has the highest exponent. So the leading coefficient in the numerator is a 5, and the leading coefficient in the denominator was a 6. So all you have to do in providing an answer for me for horizontal asymptote, if your degrees are the same, is just type out y equals, put your fraction bar, the leading coefficient of the numerator over the leading coefficient of the denominator. If the fraction can reduce, go ahead and do so. In this particular problem, it cannot be reduced. So y equals 5, 6 is our answer. The other two conditions that you are seeing says that if the numerator degree was actually smaller than the denominator degree, all you would have to do is write y equals 0. Okay? If the numerator degree is smaller than the denominator degree. If the vice versa happened, if the degree upstairs was bigger than the one below, you are going to tell me that there are no horizontal asymptotes. Okay? And remember, horizontal asymptotes, horizontal means left and right, and the lines for horizontal asymptotes will be dashed. I didn't mention, but the vertical asymptotes obviously are going to be up and down, and they too, when you graph, are going to graph them as dashed lines. Okay. Let us move on. Let's go see about x-intercepts. This is our third to last problem. Finding x-intercepts. So if you would, go ahead and copy this problem down, pause the video, and come back. All right, so finding x-intercepts. What is this all about? So let me circle x-intercepts. X-intercepts tells us to set your numerator factors. So instead of denominator, we're going to set the numerator factors equal to 0. And I should say set remaining numerator factors. So let me write the word remaining, because you do need to factor the entire thing. Okay? So set the remaining numerator factors equal to 0. So we have 5x squared minus 12x plus 4 over x squared plus x minus 90. We need to factor the numerator and the denominator. So notice we have a trinomial, 5x squared minus 12x plus 4. None of these three numbers can be divided by a GCF. They don't have a common term, so we're just going to go straight and figure out how to factor this trinomial. Here, though, I want you to realize that this a value is not equal to 1. So that's the one that I'm going to put a little squiggly line there for a frown of sorts, because that's the one that students tend to not remember. And so I need you guys to please make a concerted effort to remember how to factor trinomials when a is not 1. When a is not 1, we cannot just go ahead and put our parentheses and put the values in. We actually have to do some factoring by grouping. So I'm going to put this note here. Wow, I can't spell factor. I need you to end up factor by grouping. Okay? So let's refresh your memory. And we've been doing this quite a while, so please make sure you take good notes if this still is a struggle. When a is not 1, I need you to ask what times what is equal to a times c. Your a in this problem is a 5, and your c in this problem is a 4. So a times c, 5 times 4, is a 20. So I'm focusing on this and this. And then the other question is, what plus what would give me the middle term, b? And in this problem, the middle term is a negative 12. After you play around with some numbers, you will discover that negative 10 times negative 2 satisfies both scenarios. So what you're going to do is rewrite this trinomial in 4 terms by making negative 12 become the sum negative 10 plus negative 2. Because isn't that what you just told me, that negative 12 is negative 10 plus negative 2? So f of x is going to equal whatever we figure. Actually, I'm not going to write that down yet. Let's take that back. Let's write the trinomial. 5x squared minus 12x plus 4 is going to be rewritten as 5x squared minus 10x minus 2x plus 4. So please notice that this middle term was rewritten as this. Okay? So it went from 3 terms to 4 terms. Okay. Now, the reason I did that is because I want the 4 terms to be split down the middle so I can find the 2 factors. First, let us factor the left side by finding the GCF. The GCF for 5 and 10 is a 5, and they both have x's, so I'm going to put 5x. And like GCF, I've said before earlier, that just means you are dividing out whatever the GCF you determined it to be. 5x squared divided by 5x is just an x. Negative 10x divided by 5x is a negative 2. I'm going to bring down whatever the sign is. In this case, my sign was a negative 2, so bring down a negative. And then I look at 2 and 4, and 2 is the highest number that goes into both of them. Both of them do not have an x, so I'm done. Open parentheses. I'm going to go back and divide both of these by negative 2 because that's my GCF. And negative 2x divided by negative 2 is an x. 4 divided by negative 2 is a negative 2. So, hooray! This factor and this factor are the same. So that's a GCF. So I'm going to pull that x minus 2 out. And what am I left with? I'm left with a 5x minus 2, which are the GCFs, and that will be the other factor. So now let's go rewrite f of x, the numerator. And the numerator, instead of it being 5x squared minus 12x plus 4, I'm going to write it as x minus 2 times 5x minus 2. Okay? Let's look at the denominator now. The denominator, guess what? It does have an a value of 1. So yay, really short process. All I have to do is what 2 numbers multiply to be negative 90, that add to be positive 1. So what are those 2 numbers? So I go straight into here. Look how I'm not doing any work. I'm going to write an x, I'm going to write an x, and whatever my answers are, that's what I'm going to put them in that missing spot. So the answers for this one will be a, let's see, 10 times 9? Yeah. a 10 and a 9 definitely makes 90, but I need the middle term to be a positive 1. So let's make positive 10, negative 9. So 10 times negative 9 is negative 90, and 10 plus negative 9 is a 1. All right? So I look at this and I try to see, can I cancel anywhere? Always look for opportunities to cancel. Oops, didn't mean to do that. Cancel, question mark. And in this case, nothing canceled. So my remaining numerator factors are these right here. These are my, whoa, what's going on here? Let's see here, there we go. My numerator factors are those. So I am just going to take those values, this one right here, set it equal to 0. I hope by now you guys see the pattern that we constantly are doing. X equals 2. Actually, let's not box that because they told us to write them as coordinate points. So I'm going to just leave it as x equals 2 for now. All right, so coordinate points is what they want us to do. And then the other one, let's set it equal to 0. 5x minus 2 equals 0. I have to add 2 on both sides. So 5x is going to be 0 plus 2, which is 2. Then I need to divide by 5 to get x isolated. So in this case, x is going to be 2/5. Since they want them in coordinate form, we can't stop there. Let's write them as x and y coordinates. So my x-intercept will be 2, 0 and 2/5, 0, because there were 2 values. And that, my friends, are the 2 x-intercepts for this problem. Okay, we had 2 of them on this one. So you would type that out as such. All right, moving on to the second to last problem. Find all the y-intercepts of the following function. Also, write them in coordinate form. So, y-intercepts, you guys definitely have done this so many times. The y-intercepts sit on the y-axis. And so what do we need to always remind ourselves is that we need to let x always be 0, because you go from the origin and you either move up or you move down the y-axis. So when finding y-intercepts, merely just substitute every x with 0 and simplify. So 2 times 0 squared minus 14 times 0 over 4 times 0 squared minus 81. Well, 0 squared is 0, times 2 is 0, minus 14 times 0 is 0. So 0 minus 0 is still going to stay 0. And 0 squared ends up being 0, and 0 minus 81 is negative 81. But we know that 0 divided by anything will still remain 0. So this one turns out to be that y-intercept ends up being at the origin. So when x is 0, right? When x is 0, so I'm going to put that as my x coordinate, my answer is also 0. So this would be the answer you would put in coordinate form. All right, example number 6, our last example. Go ahead and copy this down, pause, and come back. Okay, the last feature we're going to go over are the wholes feature. Wholes are going to be found by doing the following. Find all canceled factors. So factors that you end up crossing out because they reduce to 1. And then I need you to set them equal to 0, and I need you to solve for those x values. So let's factor. F of x is equal to, always factor. Yay. Aren't you happy? We have A is equal to 1, smiley face. So let's just go ahead and put parentheses and put our X's and then ask ourselves what two numbers multiply to be 40 that at the same time add to be 13. Okay? So, what are those? 8 times 5. So I write that down. 8 times 5 is 40. 8 plus 5 is 13. Downstairs, definitely not a trinomial. We are going to use the GCF to help us with that one. And the greatest common factor here looks like they both have an X. So I'm going to write down my GCF. And if I divide both of those, x squared and 8x, by an X, what do I get? I get an X plus an 8. Proceed to see if you have any like factors. This canceled and this canceled. And that caused my function to reduce to x plus 5 over x. So when I'm looking for holes, I look for those cross-out opportunities. So here's the hole. I have to take that crossed out factor and set it equal to 0. I need to solve for x, and in this case, my x is going to be -8. But I'm not done because in this instructions, they want me to find the coordinates of the hole, and I only found x. I need to go find y. So find y. Okay, so how do I find y? Well, I just put my x back into the equation. So f of -8 is going to be that x plus 5 over x needs to replace every x with -8. So -8 plus 5 over -8 is going to give me, well, -8 plus 5 is a -3 over a -8, and those two negatives become positive 3/8. So the coordinates of my hole are going to be x comma y, where x is -8 and my y was 3 over 8. And that is how you find the holes of any rational function. And yes, you can have more than one hole occur, but in this case, there was only one.